We're recording the session, so thanks for stopping by. This is the first session for week 2, and we're hosting it on Monday. As you know, I have some travel plans, and so what I want to do first is, I know that we have a smaller crowd tonight, but I want to ask you if next week I'm scheduled to fly back on Tuesday night. So my plan was to host a webinar session, the first one on Wednesday and then the second on Thursday. So would that work with everyone? And if yes, just say yes. Um, that would be awesome. Great. Okay. And then don't forget, we record these sessions. So if for some reason you have to miss them, you can always view them later. Okay. So the other thing, don't forget, Professor David's website has all the webinar sessions from the previous term. So you can always view those if you want to get started early. Okay. Um, okay, so let me share my screen first and then we'll get started. You can tell me if you can see my screen. Yes, thank you for the reminder. I think I've already updated next week's schedule, but I will take a look again tonight. Thank you for the reminder. Um, I want to show you something real nice that was just posted later last week, and you're all gonna love it. When you go into your course in Blackboard, you're going to see an option called STEM Learning Community. Okay, so let's click on this and see what happens. By the way, you can see this, right? I hope I don't have to zoom in more. Okay, so when you click on this, this thing opens, all right? Now let me show you what this is because it's really cool. Somebody had asked about what it is. It does take a little bit of time to open fully, so I'm not sure why, but give it some time to, open properly. And then once it's opened, um, you're going to see there's a link for Math 130 and 240. So let's click on this. Okay, and then you're gonna be then you're gonna be in this mathematics learning community. Okay, this is a community which was recently started, and this is where you can actually get instant help for your questions on the homework assignment, or anything, anything related to Math 240. So what you can do, for example, something I was looking at today was you can book a tutor. So if I click on this, there's a link here, book now. So what this does is it will reserve a peer tutoring session now through Appointment Plus. So your tutor will confirm your appointment time and link to the Blackboard Collaborate meeting space. So I think you should, if you have any questions, try this out, and what I'm gonna do is I'm gonna get your feedback. I'll get your feedback tomorrow if any one of you tries this, or maybe next week, early next week, and I want to see what you think of this. Okay? Or you can also, just write to me, send me an email, and tell me what you think. Um, you know, just to get a feel for how it is. This is something new that we have recently started, so it will be great to get some feedback. Okay. All right. So the other thing I want to talk about is, so I've already talked about next week's schedule, which you're all okay with. That's excellent. And then the other thing I want to talk about is, don't forget, the second session this week is tomorrow. Okay. So then I'll be out Wednesday through next Tuesday. So the second session will be hosted tomorrow at 9 p.m. Eastern Time. Okay. All right. Any questions? This is, well, it's a continuation. So we're going to talk about Module 2 tonight. So we're going to start with Module 2. And how many of you remember that survey we did last week for the World Series? Anyone remember that? Well, I don't know if that survey is going to be correct, but it does show that sometimes when surveys are biased, then you can get, incorrect um, estimates from them. Okay. So don't forget that all surveys, when we do samples or surveys, we have to try and, have them be unbiased. Okay. And they have to represent the population properly. Okay. That's what we learned from that one survey. Okay. Last week's webinar. So last week's webinar, the links are posted here. So when you are in your course shell, click on webinar information and then scroll down, and then you'll see this course calendar. Okay, and then last week's session is recorded here on the 25th, Tuesday. Here's the recording, webinar recording. Click it, and then you can click here, and you'll see the first session, and then the second session is here on Thursday. Okay, so similarly, tonight's session I will post on Monday, and then tomorrow's session will be posted here on Tuesday, November the 1st. Okay, and of course, it's also on Professor David's website. All right, so let's see what we have for this week. So I'm going to start with the homework assignment and let's get started. All right, the first question. Oh, let me first ask you if you have any questions before I get started here. Yes, Brian, we're going to cover that tonight. Tonight is all about normal distribution. Okay, I'll let everyone else answer Christine's question. All right, so here's the first question. This you should be able to answer this without knowing anything. So let's see. A study was conducted that resulted in the following relative frequency histogram. Determine whether or not the histogram indicates that a normal distribution could be used as a model. So can we use a normal distribution model for something that looks like this? A lot of you are saying no, and Sarah has the correct answer. Why? Because it is not bell-shaped. And we all know that a normal distribution looks like a bell-shaped curve. So a normal distribution, the shape of the normal distribution is bell-shaped. Okay. So therefore, we cannot use normal distribution in this case. And so the correct answer is B. Histogram is not bell-shaped, so a normal distribution could not be used as a model for the variable. Okay. I think this was a fairly straightforward question. So let's go forward. How about this one? Now this is, oh, by the way, in this diagram, where's the skew? Tail. Where's the tail? Very good. Nope, nope. Skewed left. It's skewed left because the tail, which is, remember I mentioned that the tail is kind of like the outliers, right? The outliers are on the left side here because most of the distribution is on the right side. So this is skewed left and this is the opposite. Okay, how about this? Can we use the normal distribution in this case? No, we cannot. Okay, so very good. Normal distribution cannot be used here because it is not bell-shaped curve. All right, good. Okay, now we need to go over the normal distribution. So let me just quickly explain what it is. Okay. The first thing I'm going to talk about is that not only it has a normal distribution, not only is it bell-shaped, but also it can come in different shapes. Okay, so for example, this is a bell-shaped curve, obviously, and it is a normal distribution, but so is this. Okay, this is also a normal distribution, right? This is a bell-shaped curve. What is the difference between these two? What do you think is the difference between these two? Spread. Yes. This is spread out much more than this. And so what did we study last week that is related to the spread of the distribution? Standard deviation, Brian, very, very good. Standard deviation is related to the spread. Remember we talked about standard deviation. When it's higher, then there's more spread. When standard deviation is lower, there's less spread. So would you agree with me that a normal distribution should have a standard deviation? Do you agree? So that we can see, we can, or not see, but we can visualize and even, do some calculations when we have a normal distribution. So you all agree with me, right? Very good. You agree that the normal distribution should have a standard deviation. Excellent. Do you also agree that there should be some, remember we talked about the measure of dispersion, right? Which was the standard deviation. Measure of dispersion or measure of spread, we said was the standard deviation. Well, remember that we also talked about measures of central tendency. Can you name a few? Can you name some measures of central tendency that we studied last week? Sarah, yes, that's a very good question. Almost all distributions do have it, but in this case, it's actually very important. Kathleen and Brian, very good. Mean, median, and mode. Remember we studied mean, median, and mode. So would you all agree that we should also have a mean and a median and a mode for this, right? Because that will tell us where's the center. Now, in this case, you already know that the center happens to be in the middle, right? And remember last week we studied that when we have a skew distribution, the mean moves in the direction of the skew. The mean moves in the direction of the outlier. Remember that? Remember I did an example where um, I introduced an outlier and the mean moved in its direction, but something didn't move. What was that? Something did not move or was resistant to the movement. The median, remember the median, and we said that the median is a better estimate when we have a skewed distribution, right? Well, in this case, the nice thing is that the mean and the median and the mode all happen to be in the center. This is the mean, and this is the median, and this is the mode. They're all in the center because this is the center that cuts the distribution in two symmetric pieces, right? This is symmetric than this, so hence it has to be the mean. It is also the median because it's right at the center of the distribution. And it is also the mode because this is where you have the highest frequency when you have y-axis, right? This has the highest frequency. So this is also the mode. So the mean, median, and the mode are all the same in this thing. Now, when we do problems on normal distribution, we're going to be primarily talking about the mean. Okay, so we're not going to really talk about the median or the mode. We're just going to talk about the mean because they're all the same. So why not just choose one of them to do the problems? And the mean is nice because the mean can be used in calculations. Even in like standard deviation. Remember the formula? We use the center as the mean. So that's why we choose the mean. Okay, so we're going to choose the mean and the standard deviation to do these problems. Okay, tell me if this is clear. We haven't gone too much into it. So if you can just tell me that this is clear, that we have to have a mean and we have to have a standard deviation. Okay, good. And everything else is the same as last week. If the standard deviation is higher, then your normal distribution is spread out more. If it's lower, then normal distribution is narrower. Okay, and the mean is the center. Okay, so this should be clear. All right, I want to talk about one more thing and then we'll do this problem. So there's a rule for the normal distribution. Let me make it bigger. By the way, if you don't like the choices of my colors here, you can let me know. Okay. All right. So there's a rule, and it's called 68. Oh, good for Halloween. That's right. That's right. I guess I should have picked black and orange, right? 68, 95, and 99.7. It's not the empirical rule. It's a slightly different rule. So let me talk about this. Okay, this is what it's called. Now let me explain what this is, because this will help you do this problem. So what this is it says when you have a normal distribution and the center is here. Okay, so this is the center. All right. Oh yeah. Sorry. I thought I was thinking about something else. Yes, empirical rule. Generally, it's in applied statistics. We also call it the 68, 95, and 99.7 rule. And actually, this is a nicer way to remember this because you'll see in 2 minutes why. I like to remember it this way, okay? And you'll see why. So here's what this rule says. When you have a center on a normal distribution, then you can have any distribution, all right? Any sort of normal distribution. 68% of the values are going to be, okay, my straight lines are going to be terrible for some reason. All right. 60, and then you can see what I did. I try to make this symmetric, but as you can see, this line is too close to the center than this. But just um, think of it as they're symmetric. All right, 68% of the values are going to be within one standard deviation. Okay, this is one standard deviation. By the way, this, remember we studied last week, is the symbol for standard deviation. 68% of the values are within one standard deviation. So this is one standard deviation and this is one standard deviation. Yes, the empirical rule. Sorry, I read that as something, I was thinking about something else, but yes. But now you know why I like to call it this, because it tells you exactly this is one standard deviation. One standard deviation plus or minus. Plus means in this direction, minus means in this direction. So plus or minus one standard deviation, you have 68% of the values. Similarly, plus or minus two standard deviation, which will be obviously bigger, will have 95% of the values. Okay, so 95% of the values. 95% of the values are going to be within this range, plus or minus two standard deviation. Okay, and then similarly, almost 99.7% of the distribution will be within plus or minus 3 standard deviations. Okay, so now you know why I like to remember this as 68, 95, and 99.7 rule. You can also type this, on Google, and it'll pull it up. And what this does is it makes you it kind of it's easy to remember what percentages lie within what standard deviations. Okay. Okay, now what I want you to do is I want you to memorize this. Okay, you have to memorize this. So please memorize this. And then now I'm going to do this problem. Okay, so here we have a normal distribution. And here are the 1 standard deviation line, 2 standard deviation line, 3 standard deviation line. So first of all, my question to you is, what is the mean, the average, or the mean for this normal distribution? Very good, minus 11. Excellent, excellent. Okay, that is correct. Minus 11 because it's the center of the normal distribution. Okay, here's a second question. What is the standard deviation? Okay, now, yep, be careful, think about it. think about it for a second. It's not that simple. You have to do some arithmetic. What is the standard deviation for this normal distribution? We're not going to use plus or minus. So just sigma. What is sigma? But Rob, you have the right answer. Yes. Very good. It is 5. Okay. Now, sometimes student will look at this and say, oh, the standard deviation is -6, right? Because -6 is one standard deviation away. But remember I said it is the difference, right? It is how far are you? This value is 5 units away from -11. Therefore, standard deviation is +5. This value is also 5 units away from the center. So again, the standard deviation is 5. One thing to remember about the standard deviation is you will never have a negative standard deviation. Okay, so always remember standard deviation can be 0 or more than 0. It will not be negative. Okay, so is that clear? So can I ask you, when is the standard deviation 0? When do we have a case when standard deviation is 0? Yes, Alfred, standard deviation is 5. When there's no spread, when all the results are the same. Yes, so for example, if you have a distribution of 5, say a sample size of 5, and all values are, say, 20. So you have 20, 20, 20, 20, 20. Well, they're all the same. There's no spread. So the standard deviation is 0, and that is the minimum you can have. Okay. So any questions on this? As you can see, one standard deviation line is 5 units away from -11. Therefore, the standard deviation is 5. Alfred, I'm not sure if I understand that question. So remember, I mentioned that you have to memorize this. So here's the one standard deviation line. So let me explain this. So here's the one standard deviation line, right? This is one standard deviation away. So for example, in this case, in the center, you had -11, right? And the question is, how far is it to get -6? So this is what you need to find. How far is -6 from -11, which is -6 is the one standard deviation line, right? So we said -11 is 5 units away from -6, right? So if it's 5 units away, meaning 1 sigma is 5, and we know that 1 is nothing, it's just sigma is 5. This is why standard deviation is 5. Got it? Excellent. Oh, I'm sorry, you were asking about the other distribution, 20? Yeah, so in 20, all of your distribution is going to be just one line, right? At 20. And so there is no spread. All 100% of the values are on one line, and therefore you don't have a spread, so there is no standard deviation. Okay. So Conrad, the answer should be 5. Remember I said standard deviation can never take a negative value. Remember from last week when we did the formula, we squared all the errors, remember? Because we square all the errors, the standard deviation can never take a negative value. Because when you square a negative error, you still get a positive number. Okay, so standard deviation will always be greater than equal to 0. Okay, you have to remember this. If you get a negative answer, then there's something wrong with the calculations. Okay, excellent. Okay, so very good. Your answers are correct. So -11 is your mean because that is the point at the center, and your sigma standard deviation is 5 because the one standard deviation line, which is at -6, is 5 units away from -11. Excellent. All right. 4. Now we're going to talk about a special distribution. So did anyone of you try these problems, by the way? Were you like scared of this Z? Did you think about what Z is? You're going to see all sorts of letters now. So a lot of times it's very, yeah, yeah, I can see how that can be very frustrating. But let me tell you what Z is. And Z is very easy. And now you'll be like, oh, it was that easy. Okay, so Z is called standard normal distribution. Okay, so this is something you have to remember. You'll have to remember this. The name of this distribution is standard normal distribution, and this is just a letter to represent that we're talking about standard normal distribution. So now your question to me should not be why do we have the Z here, because now you know Z just represents a standard normal distribution. Your question to me should be, what is a standard normal distribution, right? So what is a standard normal distribution? Very simple, very easy, but you do have to memorize it. Okay, so you do have to remember this. Standard normal distribution is something that has mean of 0 and standard deviation of 1. How easy was that? Therefore, Z just represents a normal distribution that has a mean of 0 and a standard deviation of 1. So the center is going to be 0, and that one standard deviation line is going to be 1. Ask me questions. Is this clear or no? I'm going to stop here because this is very, very important. It's very important to know what we're talking about here. Okay, so 2 of you said no. So ask me question exactly what, and maybe I can go over it one more time. So let me go over it one more time and then we'll see. Then that, Alfred, then that would not be a standard normal distribution. That is not a Z. No, Cheryl. Remember I said it can be in both directions. We're just representing. It can be in both direction, right? I remember I said it's plus or minus 1 standard deviation, right? So it's just a way. I do it on the right side because it's just a way to. You can choose the left side or the right side. That doesn't really matter. But whenever you have a standard deviation, remember the 68% rule says all these values in both the directions are 68% if it's 1 standard deviation away. Okay. Okay, so I'm going to explain it one more time and then we'll move forward. Z is called the standard normal distribution that has a mean of 0 and standard deviation of 1. That is all. There's nothing to it, nothing else to it. Z is just a letter that represents a normal distribution with these parameters. That's all. Okay? So is this absolutely clear or no? Kiela, remember last week we obtained the standard deviation. So I would say go over, I believe it was the first lecture when we calculated the standard deviation. So there's a formula associated with it. So go over that. David, so don't think of this as a graph, okay? Because you can have other standard deviation, other normal distributions. So for example, take a look at this distribution. Okay, so here's a distribution. But the center could be, say, +5. Okay, now for this, the mean is +5. Is this Z? No, This is not a Z distribution, right? Even though they both have a normal distribution shape, this is not Z. This is some other distribution, okay? Z is a special distribution that has a mean of 0, standard deviation of 1, okay? Let me tell you why that is. You don't need to know this, but I will tell you anyway. Any other distribution like this can be converted to Z, okay? Because Z is like standardizing. This is the reason why we call it standard, because you take any other normal distribution that has whatever mean you have and you standardize it and you get this distribution, okay? So whatever you have, whatever distribution you have, you can standardize it. Now you don't need to know how to do that, but I'm just saying this is the reason why it's called standard, because everything, all of the distribution, normal distributions are converted to Z distribution, and then we do all sorts of calculations that we're going to do tonight. This is the only reason you need to know the standard normal distribution, okay? This is normal, but it's not standard normal distribution. Yes, Rob, that is correct. This is standard normal distribution, okay? All right. So now let me show you. I'm going to do a few tricks with you, and then we're going to do the problem. So naturally, if my center, I want to draw a better center this time. Okay. So this is a Z distribution, okay? Here's 0. The center is 0, and this is, I'm saying that this is a normal distribution, okay? Now, let me ask you a question. If I say that I'm interested in, so this is capital Z, by the way, okay? This is capital Z represents a normal, standard normal distribution. We can use small z's, small letter z. So, maybe I'll use something like this for it. Small letter z to represent values on these lines, on this line, okay? So these are all, obviously they can be different values. Here's 0. So this will be positive side, this will be negative side. Tell me where would be z equals 2. So maybe what I should do is, hold on, I'm gonna draw better units. Okay. So I'm gonna say that this is 1, this is 2, 3, minus 1, minus 2, minus 3. So tell me where z equals 1.5. Is it on the right side or is it on the left side? This is plus 1.5. So on the right side, right? Is it here? Is it this point? Is it this point? No. Is it this point? Yes. Okay, very good. It's this point. It's this point right here. Where is z equals minus 2.5? Is it here? Very good. So you're all right. You're absolutely correct. This is on the left side. Is it here? Yes. Very good. Between that and that. Excellent. Okay. Excellent. So now you know where the values are. Okay. When you have a standard normal distribution where your mean is 0, all the positive values are on the right side, all the negative values are on the left side. And now you were able to distinguish, even though you didn't realize probably, you were able to distinguish that 1.5 plus 1.5, which is 1.5 units to the right of the mean, is closer to the center line than minus 2.5 units, which is much further away, right, than the center line. You didn't think about it, but you were able to almost distinguish that, right? It's much, much further away than 1.5, okay? Okay, now let me ask you another question. If I tell you to highlight, so what I'm gonna ask you is highlight highlight area that is z greater than plus 1.5. Which area would you highlight? So we already said this is 1.5 line, right? This is 1.5. So would you highlight this area? So is this the area you would highlight for this? No. Okay. Let me ask you, is this the area you would highlight for this? No. Very good. So would you say you highlight this area? Very good. Yes, that's the area you're going to highlight. Okay. Donna, that's because I'm asking for to highlight area that has values of z greater than 1.5 plus 1.5. So where is z greater than 1.5? This whole region has z greater than 1.5, right? 1.5 is right here. So obviously you have 2, 2.5, 3, and all these values in the middle, right? Yeah, this is the greater than sign. Okay, excellent. Now let me ask you, how about we highlight z less than minus 2.5. So minus 2.5 was here. So which area am I highlighting now? Brian, that be careful. I need less than minus 2.5, not plus 2.5, right? Okay, so let me ask you. I'll take a poll. I want z to be less than minus 2.5. So am I highlighting all this area? Yes or no? No, because here all the z's are greater than minus 2.5. So that's not the area I'm highlighting. Am I highlighting this area? Yes, absolutely right. I'm going to highlight the area to the left, which is less than minus 2.5. Very good. Okay, let me ask you a challenging question now. Okay, this is a challenging question. If I was to highlight less than 0, would you say that area is equal to z greater than 0? Would you say that's true or no? If the region that is on the left of 0, is that equal to the region that is greater than 0? Is that true or no? Okay. Some are saying no, most are saying yes. So let me tell you the correct answer is yes. So let me ask you, if you said no, let me know why you think that. Let's see what kind of, because sometimes we get really good questions when that's the case, and I want to answer those questions. Yes, Brian, that is correct. The area is symmetrical. So I think some of you said no, so let me tell you why that's not true. Z less than 0, right? Z less than 0 is all this area, okay? Okay. And we said that the mean is at the center. And we said that at the center makes the normal distribution symmetric. Remember we said that? The center here, the normal distribution is symmetric at the center. So they must be equal. These two areas have to be equal. Don't go with my drawing, Conrad, because my drawing can be, it's a little distorted, of course. I'm hand drawing this. But for a normal distribution, the area to the right of the center is equal to the area on the left of the center. Okay. Isn't it funny? I use blue and red, kind of goes by the two political parties that we have, and and we're talking about probabilities in a way, Yeah. Anyway, so you all agree with that. Very good. Okay. Excellent. I want to talk about one more thing and then we'll go back to the question. Okay, so here's the normal distribution. Center is 0. Here's something I want to talk about. So say we have a value here, and maybe this is 2. Okay. So remember when we said I had to highlight z greater than 2, or I have to, every time I do problems, I'll have to tell you to highlight z greater than plus 2. Well, why not use some notation for this highlight word? This is, too cumbersome to write. So how about we don't write this? How about I represent this whole thing with something like this? How about I say, and let me tell you what this is. Yes, Peter? It includes area to the right of 2. How about I say something like this? Okay. Peter, that's a very good question. So Peter just asked, so let me stop here. Let me answer that question because that's a good question. So Peter asked, when I say highlight z greater than 2, does that mean that I'm also saying highlight z greater than or equal to 2, right? In other words, do we know if greater and greater than equal is the same when we talk about normal distribution? So Sarah, you have the correct answer, but that is correct only for discrete distributions. And I forgot to mention that normal distribution is a continuous distribution. When you have continuous distributions, then greater than or equal or greater mean the same thing. So when I say greater than plus 2, it means I am also implying that is greater than or equal to plus 2, which means 2 is always included. Okay? So when I highlight this area, it means that I'm also including 2. And the reason is that this is a continuous distribution. It is not a discrete distribution. When you have a discrete distribution, then Sarah's answer is correct. Discrete distribution meaning, for example, you have bars, for example, right? So here's 1, 2, 3. Maybe you have this, and you have a frequency histogram. Remember we did those last week? This is 15 and 5. So maybe you have like this and this and this, right? So there's nothing in the middle, right? They're disjoint in the middle, not like this. Everything is connected here, right? Here they're disjoint. So if I say z greater than 2 here in this case, this is a discrete distribution. When I say greater than 2, it literally means greater than 2. 2 is not included, so only 3. Okay, so this is the difference here. But to answer your question, for normal distribution, they mean the same thing. So whenever you get questions that have greater than or equal to, or that just have greater than, don't be confused with that. Okay. All right, so let me cross this out. Okay, now I'm going to go back to saying what I was mentioning here, which was, how about I not write this whole highlight thing and I just say P of z greater than plus 2. Okay, this basically means I want you to highlight the area that is z greater than whatever number I gave you. Okay, do you know what P stands for? Any suggestions, any guesses what P means, could mean? Aha, aha, it means probability. Aha, probability. So what am I asking here? I'm asking find the probability that z is greater than plus 2. So let me ask you a question. If I'm implying that this highlighted area under the curve is actually probability, then what is the area of this entire curve? Let me ask you the question again. Oh, Peter just answered. Peter, you just ruined the question. No, I'm just kidding. Peter actually gave the correct answer. And the reason is because probability, oh, well, let's see if someone knows that. Why does the area, why is the area 1? Aha, because probability should always sum to 1. Probability must always sum to 1. It cannot be more than 1, cannot be less than 0. Okay? So in other words, the entire area under the curve is going to be 1. 100%. Yes. Okay. Let me ask you one other trick question. We go back to the actual problem then. This is going to be a little bit of a trick question, but I think you'll all get it. So we all agreed that the area of the entire region under the normal curve is 1. What is this value? You guys are good. Yes, it's 0.5. Very good. I didn't even have to explain that. So probability that z is greater than 0 is 0.5. How? Well, we just said that the probability under the entire curve is 1, right? So who asked that question? Cheryl. So Cheryl, do you agree that we said that the probability under the entire curve is 1? Do you agree with that? Okay. If you agree with that the entire probability is 1, then we just said that the center cuts the graph in half. So wouldn't the probability greater than 0 then be 1 over 2 or 0.5, right? Got it, right? Because if the whole thing is 1 and I'm cutting the graph in half, then this is 0.5, right? So similarly, when I say less than 0, that's also 0.5. This is also 0.5, right? So now you should all be ready to do all these problems. No, Alfred, not minus 0.5, because remember, probability can never be negative. It has to be between 0 and 1. I'm not talking about the actual values on this line. The values will be negative. Like z, small z can be negative, right? If I ask you minus 1, probability that z is less than minus 1. Remember that? That can be negative. But the area under the curve cannot be negative because that is probability. Okay? And Rob just answered the question better than I actually did, because you cannot have a negative 20% chance of rain. Probability cannot be negative. Okay, now let's do some problems because I think that will help you understand this further. So let's do this problem now. So now you're not going to be confused with this, right? It's kind of like, I think I mentioned this last week also. Statistics is like the matrix. Once you start learning all these letters, they start making sense to you. So now you know what the z is, right? You can decipher the z here means you have a normal distribution, standard normal distribution with mean 0, standard deviation 1, right? So let's do these problems. All right, the first one, I'm going to draw this real quick. I want to cover at least 10 problems tonight. So here's part A. I want to determine the area under the standard normal curve. So they actually told you a standard normal. So you should already know that mean is 0, standard deviation is 1. That lies to the left of z 1.72. So first of all, you have to draw the 0 line, right? So I'm going to draw the 0 line here. Okay, where is z 1.72? Is it on this side? No, it's on the right side. So it's somewhere here. Let's just draw somewhere here. 1.72. Area to the left of z 1.72. So where is the highlighted area? To the left of z 1.72. So this area, let me turn off this. Is to the left. Yes, so this whole area. Very good. So how do we find this? The question is, determine the area. We need to find what is this area, the value for this area. Okay. So how do we do this? Well, StatCrunch is our friend. I'm going to open StatCrunch and then I'll show you what it is. Okay. So my suggestion to you is always draw out this curve. Always, always for these problems, draw it out. If you're not going to draw it out, you're going to get confused. These problems can be confusing if you don't visualize them. From now on, from now until the end of the course, if half of the statistics is art and the other half is science. You have to sort of visualize things in statistics to really understand them, which is why I spent significant amount of time on this stuff today. So now the first thing you do when you read the problem is draw it out. Now that you have it drawn out, now you go to StatCrunch and then I'll show you how to do the problem. Okay, Lasanti, sorry, but you can always view the recording. All right. I hope I said your name correctly. I'm sorry if I didn't. Okay, so here's how to solve it. Okay, so everyone follow now. I'm going to click on Stat and I'm going to click on Calculators. And you'll see that it has calculators for all kinds of distributions. And I'm going to click on, where am I going to click on? It's very obvious now. There's a calculator that I'm going to click on and it's called the normal calculator. Yes, right? It's pretty obvious. All right, so, and voila, what do you see? You see a normal distribution, don't you? And what do you see? You see a standard normal distribution. It even says standard. The center is at 0. And now you know what it means. All the plus z values are on this side, minus z values are on this side. Okay? Here's a mean. You can enter the mean of the distribution and the standard deviation of the distribution, right? We're talking about standard normal in this problem. So its mean is 0, standard deviation is 1. Great. Everything is good. Now, don't be confused with this x or z. They're just using a notation x. The reason they don't use z here is because I can change these values. I can change the mean, but now it's not a standard normal distribution anymore. It's some other normal distribution. So therefore, they don't want to go through the hassle of changing the z to an x or some other letter to represent that distribution. So they just call it x. Okay. But we know that when you have a 0 and 1, it's a z distribution. How do you think I'm going to calculate this probability that z is less than 1.72? I only have to do one thing here to calculate that probability. What do you think it is? Yeah, exactly. Change this 0 to 1.72 and hit compute. Look at this. It calculates the probability, and not only that it gives you the answer, calculates the probability, but it actually draws it out for you. You see this? It actually, drew the diagram, showed you the area under the region that it highlighted, that it calculated for you as well. And this diagram matches with what you had guessed before you actually solved the problem. Isn't it? So do you all agree that it actually helps to draw it out yourself so that you can see what you get and then say, aha, I'm correct. You will never be wrong if you draw it out yourself. And it takes just a pen and a piece of paper to draw it out. Okay. Yes, so I'm going to go over the tables as well, the paper tables, that are in the book, but that's really um, an inefficient way of solving the problem. I will show you how to do it because I think you should all know, but I want to start here, which is the easier method. So the answer for this problem is 0.9573 up to 4 decimal places. So if you look at the answer, 0.9573 is the correct answer. Okay, so let's do this one. Let's do the second one. Okay, you're gonna help me with this. Where is z less than, z area to the left of z minus 0.63? First of all, where's minus 0.63? Is it here? Somewhere here on the right side? On the left side, yes. So it's here somewhere. Let me use the same color so that you don't get confused. Area to the left of z minus 2.6 minus 0.63 to the left. So which area? Is it this area? No, it's this area. Yes, very good. Okay, so now you know how the drawing looks like. Let's go here. And maybe, actually, once you practice a little bit more, you'll learn that this line should be closer to 0 or much further away from 0. You'll learn that as you do the problem. So right now I just randomly picked a point on the left side and I said this is minus 0.63. You'll learn that this should be a little closer towards 0. Okay, this is something that'll come as you do more practice. But let's solve the problem. Go back to StatCrunch, less than minus 0.63. That's all you have to do. Probability that you want x to be less than or equal to minus 0.63. Hit compute. Look at this, 0.2643. That's the answer. And you can see that it matches with the diagram that you had. And you can see, remember I said it's a little bit closer to 0 in this case, but that's something you're just going to learn as you practice drawing these. Okay? Okay, so the rest of these two are exactly the same as the one we did. So my question to you now is this clear? Is this problem clear? Can you, put these values, the z values on the graph and then highlight the right region, left or right or whatever? Okay, great. How about that? Excellent. Okay, let's do another problem. So now we want determine the area under the standard normal curve that lies between two values. Haha. Well, now we're talking, now we're getting a little more, you know, we're gonna have a little bit of fun now. Okay. The problems are gonna get a little bit confusing. So you're gonna help me highlight the right region. Determine the area under the standard normal curve. Again, it's standard normal, so we know the center is 0. That lies between these two values. Okay, between these two values. So let's say, where is 2.14? 2.14 is here somewhere, right? So maybe it's here somewhere. Okay, okay. And then where's minus 2.14? Well, it's on the other side, almost, actually exactly as far as this thing is, right? Equal distance from the 0. Kathleen, excellent point. They're all equidistant from the center, both of the values, but one is in the left direction, the other is in the positive direction. So minus 2.14, 2.14. Excellent. And so what area am I highlighting? Determine the area under standard normal curve that lies between the two values. So which area am I highlighting here? Yes, this area. Do you all agree is this area? Very, very good. All right, this is what we want. How do we get this? Let's go to StatCrunch. So look at this. There's an option called between. Let's click on this. Aha. It helps us calculate areas in the middle of two values. How awesome is that? So now all I have to do is type minus 2.14 and 2.14, and look at this. It gives you exactly the area that you predicted, and the value is minus 0.9676. That's your probability under the normal curve between these two values, 0.9676. What do you think? Sweet, right? Let's do one more. Let's do one more. All right, so I'm going to say center is again at 0. Okay, let's do this one. So where is this? Between minus 2.78 and 0. Obviously, the 0 is in the center, right? 0 is in the center, right? So this is that line. Where is minus 2.78? It is right here somewhere, maybe a little bit further away, minus 2.78, right? And where's the shaded area? The shaded area is this. Yes, yes, this only. Very good. All right, let's calculate it. Let's see what we get. So I need minus 2.78 and 0. Again, the mean is 0, standard deviation is 1, and I want area between minus 2.78 and 0. So hit compute, and look at this. It gave you exactly what we anticipated, and the answer is 0.4973. You can see that this matches, first of all, this matches the drawing that you had, right? They're both the same, and the answer is 0.4973 is the answer. 0.4973. Okay, is this clear? Is this problem clear now? I'm sure you can do the third part yourself. Should be very simple. And of course, your values in your homework assignment are going to be different. So you're going to get different answers. So you cannot just copy these and paste them and get the correct answer. You'll have to actually do these problems. But now you know how to do it. Very good. Let's move on. Okay, pretty much the same question. I'm going to go over the table method tomorrow, but determine the total area under the standard normal curve in parts A through C. So again, this is very much the same. So let's just pick one. Which one do you want to do? Minus 2 and 2, minus 1.58 and this. Let's do okay, let's do B. So here's B, and what I want to do, how about I just do it on this? So all right, so the part B says between Z minus 1.58 and 2.58. So where is 2.58? It is here somewhere, right? And minus 1.58 is somewhere here, but obviously closer to 0 than 2.58. So it's maybe like here somewhere. Okay. Then whoops, let me minus 1.58. And then I highlight the area. That's what we need. So, my God, you understand it. All right, so minus 1.58 and 2.58. So minus 1.58 and 2.58. Okay, again, I'm not going to change this. I'm not going to change the mean and the standard deviation because we're talking about standard normal distribution, right? So keep that the same. Put the values that you're looking for, highlight the area, you get 0.9380. That is the answer. The diagram matches what you had. That makes you happy. Okay, we actually did the wrong problem, so it should not make you happy, it should make you sad because we calculated the middle region, right? Well, the question, we didn't even read the question. The question said, find the area under the normal curve to the left of minus 1.58 plus the area under the normal curve to the right of Z 2 points. So see, they're asking for a different area. So let's stop here for now. So you have to help me highlight the right area. I promise I wasn't trying to trick you. I actually did not read the question myself. So yes, that's right. So which area am I highlighting here? So find the area under normal curve to the left of z minus 1.58. So let's highlight that. Where's normal curve to the left of z minus 1.58? So we're talking about this area. Do you all agree that it's this area? Left of z minus 1.58? Okay, you agree. Plus, they want you to take that area and they want you to add it to the area to the right of z 2.58. So where's z to the right of 2.58? Do you agree that is this area? Aha. Okay, now this is a question. Now, if you were in my class, I would give you extra credit points for getting this question correct because this is a little bit of a tricky question. So how do we find this? We don't have a way to calculate the edge areas in StatCrunch. How can we find this area? How do we find this area? Any question? Sarah, you're right. We can do one at a time. We can first calculate this area. So we have to go back to standard option. So first we calculate z less than minus 1.58. We get this area. And then we add this area. And then we now find z greater than 2.58. We find this area. So then we take this area, add it to the previous area that we calculated, right? That's one way to do it. Any other method? Can we do this in one step or maybe one or two steps? Because this involved several steps. Can we do this in one or I sense a better way coming? Yes, I also do. I sense a better way coming. We can't do that. Can't change the greater than sign here, unfortunately. Aha, Chris. Chris, are you the one who gave that answer the first time? Is Chris the first one to give this answer? Or did anyone else give this answer also? Because if Chris, if you're the first one to give that answer, you're the winner. Chris got it. Yes. Okay, here's the trick. So what I'm going to do is this. Let's try to follow this. I'm going to try and find this area because StatCrunch gives me that area, right? And I calculated that area to be 0.9380. Okay, the middle area between the two values is 0.9380. So I'm going to write that down. The area in green is 0.9380. Is everyone following this? Did you all follow how I got 0.9380? No. Okay. You see minus 1.58 and 2.58? I just found the area in the middle of those two values, which is, see that's minus 1.58, 2.58. The area is 0.9380. Okay, that's all I did. So that's this area. And Chris says, take this and subtract from 1. Why is he subtracting from 1? Why is he subtracting from 1? Yes, everyone's got it now. Because because we said the area under the curve, the entire curve is 1. So obviously if I take 1 and I subtract the middle area, I get the region on the two ends, the red region, right? So this is 1 minus 0.9380. I can easily find that in the calculator and I get 0.062. 0.062. This is the area on these edge regions, the sum of the two areas on the edges. Does that make sense? Everything must equal 1. Got that right. You can do it any way you want. Like I said, you can do this in 2 steps. You can first find this area, then find this area, then add them together. That's one way to get the answer. The other way is to do this trick where you find the middle area because StatCrunch gives you that, and then just subtract this from 1, and then all the area that's left are these edge areas. And you don't need to do any additions anymore because the answer you get is the sum of the two areas already. So we were sad before, now we're happy. Does that make sense? Does this make sense now? This was a little bit of a trick question, I think. But my aim is for you to think about all these different ways of doing these problems. Okay, now you know how it has to add up to 1. You can find the middle region, then subtract from 1 to find the edge cases. You can do any problems, whether the area is in the center or on the left side or on the right side, whatever. Just gotta read the question. Don't do the mistake that I just did. Okay, and then the others are pretty much the same. Okay, so find the area under the normal curve to the left of z minus 2 and to the right of z2. So how do I do that? Let me just put left of z minus 2 and to the right of z2. So I'm going to find the middle area between the two values. I get 0.9544, and then I can just subtract this from 1. And again, I get the edge cases. I get 0.0455. Up to 4 decimal places is 0.0455, right? Any questions on this? Christine, always round the final answer, okay? Always round the final answer. When you get the final answer, then do the rounding. Do not round before that. Yeah, so whenever you're doing your calculations, do not round until the last step. Okay, excellent. No questions. Looks like you all got it. Let me move forward. I want to do a few more problems and then we'll call it a night. Yeah, Donna, this is just per question. So some questions, most of these questions this week will say 4 decimal places. So that's just the way the question is asked. Okay, now let's talk about this. My first question to you is, after reading this problem, tell me if we're talking about z or not. Assume the random variable x is normally distributed with mean 50 and standard deviation 7. Is this a z distribution? No, because the mean is not 0 and the standard deviation is not 1. Both conditions have to be correct for this to be a z distribution. The mean must be 0 and standard deviation must be 1. They both have to be correct. Even if one is correct and the other is not correct, you still don't have z. Okay? So this is not a z distribution. This is some other normal distribution. Compute the probability. Be sure to draw a normal curve, blah, blah, blah. All right. So first of all, let me draw this out. Okay, the mean is 50. So what is the center value? Mean is 50. So the center is 50. Yep. Okay, and we want probability. So now they're representing this with letter x. So this is an x distribution. We need probability that x is greater than 42. So where is 42 first of all here? Where's 42? On the right side or the left side? It's on the left side, right? So it's maybe like somewhere here. 1 standard deviation away is 50 minus 7, which is 43 is 1 standard deviation away. So 42 is probably here somewhere. And where is this area? X is greater than 42. So what area are we talking about? Area to the right side of it or to the left side of it? Area to the right side of it. So I'm talking about this area. Okay. Awesome. You guys are awesome. You are all getting this. This is awesome. Okay, so you just answered the first question because you just have to match the correct graph, and you just told me that this is the graph and it matches with part C. Okay, this is not right. This is not right. This is the right answer. How do we find this? So how do we find this in this normal calculator? I'm going to go there again. So I'm going to go to Stat, Calculators, Normal. How do we do this problem? Take me through this step by step. Enter 50 for the mean. Rob is correct. Okay. 7 for the standard deviation. Okay. And I need x greater than 42. Okay, what else? Greater than 42. What else am I going to do? Change the sign. Yes, I can absolutely change the sign. Take a look at this. I click on it. I get a drop down. I can choose either one. Change the symbol to greater than. And what is the value that I'm looking for? 42. I'm going to enter 42. Hit compute. And here's the answer. 0.8735. That's up to 4 decimal places. 0.8735. And look at the diagram matches what you were anticipating. See that? Matches exactly. So 0.8735 is your correct answer. 0.8735. So what do you think? Good so far? Sarah, as I mentioned earlier, it doesn't matter. In continuous distribution, greater than or greater than equal to, they both mean the same thing. For a continuous distribution, normal distribution is a continuous distribution. In this case, it doesn't matter if you have less than or equal to. They both mean the same thing. It only matters when you have the discrete distribution. Okay, great. All right, let's go to the next problem. Pretty much the same. So now we're talking about, see if we can do 2 more problems maybe. Okay, so now we have, whoops, I like black for this. Okay, so the mean is 50. So obviously my center is 50. And what am I looking for? 34, between 34 and 59. So where's 34? On the left or the right? Left, yes. So 34, maybe here somewhere. And 59 is on the right side. Now you can see that standard deviation is 7. So 1 standard deviation away is 57. So 59 is maybe like somewhere here, right? Okay, now let's highlight what are we looking for? Are we looking for the area in the middle or the area on the 2 edges? What are we looking for? We're looking for area in the middle. Yes, because we're talking about x between 34 and 59. So this is the area we're looking for. We're not going to repeat the mistake we made earlier. We're going to read the problem this time, right? So you just answered one of the questions. Which area is correct? You can see that this is not correct because it highlights the entire region on the left side. This is not correct because we're not going to make the mistake that we made earlier, right? It's not an edge case. This is the right area that we're looking for. Christine, because note the problem says probability that x is less than 59 and greater than 34. You see that? It says it's less than 59 and it is greater than 54. Both conditions have to be true. So less than 59, 59 is here, okay? No, there's no default here. This is very clear. So, right, I mean, X should be between 59 and 34. So between 34 and 59 means it has to be the area in the middle of the two, right? Does that make sense? Yes, or like Rob is saying, Rob actually has a very good solution, is to consider this as two different scenarios where X is less than 59 and X is greater than 34. Both conditions must be true. So you can think of it this way as well. And when you think of it this way, then you will always end up with this scenario. Okay? Rob, that's a very good suggestion. Thanks for pointing that out. Makes better, yeah. So we should thank Rob for that. Excellent. Okay, so we just got that. Now let's do this problem now. All right, so we're gonna go to StatCrunch. Same problem, we have 50 and 7. Okay, 50 as the mean, 7 as the standard deviation, but we need to go to the between option and then enter the two values, 34 and 59. Okay, everything here looks good. Compute 0.8896. And let's see if that's the right answer. 0.8896. That makes me happy. Any questions here? Problem 10 we're going to have to do tomorrow. This involves, I'm going to show you a really cool simulation on this tomorrow. So I'll give you a hint tonight. So maybe you'll be so excited that you're not going to be able to sleep. No, I'm just kidding. All right, so so now we actually have a real life example. Isn't that nice? I mean, you studied all this normal distribution and you're probably like, what is all this? You know, where is it used? Well, here's a real life example. The mean gas mileage for a hybrid car is 57. Before I go, remind me, I'm going to tell you two applications of normal distribution that you probably see every day in your life and you don't realize it. Please remind me, okay? Okay, mean gas mileage is 57 miles per gallon. Suppose that the gasoline mileage is approximately normally distributed with standard deviation of 3.5. So tell me, since they're already told you that this is a normal distribution, what is the mean? The mean is 57. Excellent. And the standard deviation is 3.5. What proportion of hybrids get over 60 miles per gallon? Okay. So Kathleen says she's lost. That's not good. Got it? Okay, got it. Okay, David, good night. We're gonna finish in about 5 minutes. So, okay. So 57 is the center of this of a hybrid car. Hybrid car on average gets 57 miles per gallon, and we said that the gasoline mileage is approximately normally distributed. All right. So question is, what proportion of hybrids get over 60 miles per gallon? I can write that as we need probability that X is greater than 60. Do you all agree that's what we're looking for? What proportions? Basically, we're looking for the probability because that'll give us percentages, right? Of hybrids get over 60 miles per gallon. This is what we're looking for. So where's 60 here? Right side or the left side? The right side. And where is greater than 60? To the right. So I'm looking for the area here. Okay. So I can easily go to StatCrunch, go to the standard option, enter 57 for the mean, and 3.5 for the standard deviation that's given in the question. Okay, 57 is the mean, 3.5 is the is the standard deviation, and I want probability that x is greater than 60. Hit compute, here's 60, and the answer is 0.1957 is the answer. So 0.1957, but they wanted proportions, right? So I wonder if they are looking for percentage. No, they're just looking for decimal points. So the answer is 0.1957. What proportions get 53 miles per gallon or less? Well, just enter 53, change this to less than sign, everything else remains the same, compute, you get 0.1265. Okay, I use the between. No, I'm at standard. It's kind of weird. It This is actually not selected, I guess. So even though it looks like it's selected, but is that the problem, or did I make a mistake or something? Yeah, this is not selected. You see, if I click here, now it gets selected. Actually, I'm on the standard option. Yeah, between has 2 points. That's right. See, between has this and this. Standard has only 1 point. Okay. So less than 53 is 0.1265. 0.1265. What proportions get between 58 and 62? So between 58 and 62. So now I have to click on between. Okay, the mean and standard deviation remains the same, and I am going to change the two values. I need 58 and 62 between the two values. So 58 and 62, and I get 0.3110. Okay, 0.3110. 3110. What is the probability that a randomly selected hybrid gets less than 45 miles per gallon? So before I answer that question, let me ask you something. 57 is the mean, the average that the hybrid cars get. Now they're saying, say I go out there and I select a randomly selected car, but it only gets maybe 45 miles per gallon. What is the probability that that would happen? Do you think this would be very less likely or very much likely? Would it be common, or it would be very less likely? Look, one standard deviation line is 3.5 away from 57. So if I create the line in this direction, this would be, what is it? 57 minus 3 is 54, so this would be 53.5. 53.5 is one standard deviation away. 2 standard deviations away is 50. And 3 standard deviations away is 3 times 3, 46.5. Yeah, right? We're talking about 45. That's even further down from 3 standard deviations. It's way down here, maybe like here somewhere. And we want less than 45, so that's this area. So that would be very less likely. See that? It's way at the tail of this distribution. So let's see what that is. So I want to go back to standard, and I want less than 45. Okay, take a look at this. Look at how unlikely that is. It's almost a zero probability, right? It's 0.0003. The nice thing is that you were able to comprehend this. Even before you saw the answer, you were able to say, just by looking at these remember the, what is it, the 68, 95, 99.7 rule, empirical rule, you were able to tell that this probability is going to be very low. And that is exactly what happened, right? It's very low. It's so low that it didn't even highlight it on this graph. It's so low. So that's the answer. Okay, now before we go, I'm gonna tell you one really cool application of this. So I'm terrible at drawings, but anyway, I'm gonna draw a hold on. I'm gonna make an attempt to draw it. Terrible drawing, but anyway. So obviously this you can think of as a water bottle, you can think of it as a any bottle, right? But really what I was thinking about was Coca-Cola. And what they do is or Pepsi. Okay, I guess I shouldn't prefer one over the other. What they do is when they fill up this um, the bottle, right, with the liquid, if I zoom into this the fill level, if I zoom in, then this is what's happening. Say this is the optimum level they want to fill it at, okay? This is the optimum level that the machine is programmed to fill the bottle, okay? But because the machine is not perfect, sometimes it will go up, sometimes it will fill less. Sometimes it will overfill, sometimes it will underfill. But most times it will try to hit the mark. And what will happen is you will get, I mean, this is literally true. I'm not making this up, okay? This is really, really true. You get a normal distribution where your fill level, the optimum level, is at the center of the distribution. And then you have this normal curve around it where the fill level varies according to this normal distribution curve. Any water bottle, water bottle, any Coke bottle, anything, Coca-Cola, Pepsi, whatever, any bottle fills. The machines are not perfect to fill the bottle at the optimum level 100% of the time. So what you will say is most times it will fill at the right level, but sometimes it will overfill. Obviously, the probability of overflowing the bottle is very low, right? Because that's way beyond the optimum level. But it actually follows a normal distribution, and that's pretty cool because if you know that this follows a normal distribution, then you can do all sorts of calculations. You can take a machine that fills a water bottle, okay? When you're testing the machine, you can say what is the probability that the fill level is, say, 3 standard deviations away from the mean. You can calculate this. If you have a mean and you have 3 standard deviations, which you can say that, oh, at 3 standard deviations, my water bottle or the bottle is gonna overfill. Okay. Well, what is that probability? Well, now you know how to calculate that. You can use anything like StatCrunch to calculate what is the probability that that would happen. If that probability is like 10%, like for example 0.10, bad machine, right? It should not be that high. It should be almost like the answer we calculated, 0.0003 or something. That the probability of overfilling is very, very small. Okay, and we're gonna end our lecture here. I think this was a good introduction. Hopefully, yes, we're gonna continue from this tomorrow. So we're gonna do problems 10 through 14 and everything that they involve. All right. All right, great, excellent. So I hope this helps you to get started with the homework. Try to do it early. and I'll be here for another 5-10 minutes to answer your questions. That's great. Okay, let me stop the recording.